Hi students, this is the beginning of Unit 11 where we dive into surface area. And I'm going to start by having you write down the definition of surface area just so that you have an idea of where this all is headed. So surface area is the sum of the areas of all of the faces of a three-dimensional figure. So last unit we were working on just regular area, two-dimensional area. This unit we are looking at three-dimensional figures and finding the area of all of those faces of that three-dimensional figure, okay? In this first lesson, we're not actually going to be working on surface area just yet, but we're going to work on naming and classifying solids, just getting a lot of the vocabulary stuff out of the way so that we're all on the same page as we go forward into more of the number crunching type stuff. So 11.1, naming and classifying solids. We'll start out with a definition of a solid. A solid is just a three-dimensional or a 3D object. Okay, so you see these all the time. You've even studied this in some of your math classes in the past. So nothing crazy here. A cylinder is like a soup can or a tennis ball container. And you're going to do your very best in this unit to draw things. Now, I am not perfect either, but I think we get something out of drawing our own pictures. I think it helps us understand things and conceptualize things a little better. So draw your best cylinder, draw your best pyramid. A pyramid is a trickier one to draw. You want to start with kind of a parallelogram, even though we kind of want that to be a square, but it's because it's on the bottom. So kind of go like that. And there's a pyramid, just like the ones in Egypt. And then a cube. I think everyone has a different way of drawing a cube. I usually draw mine like this. Again, by no means perfect, but a cube is like dice are cubes. Okay, now moving on to this fancier name, polyhedron is a singular name for a solid with flat sides and straight edges. Polyhedra is the plural if you were talking about multiple solids, but a polyhedron is a solid with flat sides and straight edges. So if we were to go back and look at the solids we already drew, and we went through and we looked at a cylinder, does a cylinder have flat faces and straight edges? No, it's got a circle here. That is not straight. So that is not a polyhedron. A pyramid, though, it does. It has all of these straight edges. Every line we drew was straight. All of the faces are flat. So that one is a polyhedron. Same with a cube. A cube is a polyhedron. So basically, anything that's got a curve in it is not considered a polyhedron. So no curves for polyhedron. For a polyhedron. All right, so now how to properly name a polyhedron. Okay, so we were very generic when we named those figures before. We just said cylinder and pyramid and cube. We were not very proper on those ones, but that's probably what you're more used to. Going forward in this unit, we're going to be a little bit more specific. So the first thing we're going to do is we're going to find the base, okay? The base is going to be a shape. It's either going to be a triangle, or it's going to be a square, or it's going to be a rectangle, or it's going to be like a pentagon. I'm not even going to draw that. I'm going to write it. It's going to be a pentagon or a hexagon. Okay, we could keep going with those. So basically, you are looking for like the base shape. It's not necessarily on the bottom, but you're looking for something that's going to be the base, that you're going to make the base. And we'll look at some examples, and that will make a little bit more sense in a minute, okay? Then you're going to look at the lateral sides. And the lateral sides are going to tell you whether it's a prism or a pyramid. So a prism has rectangular sides. And a pyramid has triangular sides. And that's how you're going to tell the difference. So for example, you might have a rectangular prism, or you might have a square pyramid, or you might have a hexagonal or hexagonal, you can decide how you want to say it, hexagonal prism. or a pentagonal or a pentagonal pyramid. So you're going to use one name from the left and one name from the right, and you're going to put it together to name the solid or the polyhedron. Okay, so we're going to start with this first kind of example here where you are going to draw the figure on the right side. We are going to name it first and then write down the faces, edges, vertices, and then something called Euler's formula. So first of all, the name of this, we want to find the base. Okay, on this one, it is totally fine to use the shape on the bottom and on the top as your base. Those are your two bases. Okay, so look at that shape. That shape to me looks like it is a rectangle. So when we're naming this, we're going to want to call it a rectangular something. Okay, now the something depends on these lateral faces. So here's a lateral face and here's another lateral face. Okay, here's another lateral face. And those are all rectangles, so it would then be called a prism. If they're triangles, it would be a pyramid. And I think that's pretty obvious that it's a prism. I don't think that looks anything like a pyramid. So maybe that's the easier way to do it, is just say that looks like a prism. It's got to be a prism. Okay, now we're going to count the faces, the edges, and the vertices. So the faces are the flat parts. Okay, so there are going to be 6 flat parts on here. We got the bottom, the top, the right, the left, the back, and the front. It's kind of hard to see the difference there. So there are going to be 6 total faces. Okay, those are your planes. Faces are planes if we're talking about basic geometry terms. Okay, edges, the edges are your lines. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 of those. Okay, and then vertices are your points. So we're looking for the pointy parts. 1, 2, 3, 4, 5, 6, 7, 8 of them. 8 pointy spots. Okay, now there's this thing called Euler's formula, and Euler's formula really just allows us to check our work. So what Euler's formula says is that if you add together your faces and your vertices, and then you subtract 2, you will always end up with your edges. And we can check it on ours. We had 6 faces plus 8 vertices. 6 plus 8 is 14. Subtract 2 is 12. So our edges should be equal to 12, which it is. So not the most important thing in the whole entire world, but it's going to work for every single polyhedron that we do. So it's kind of nice to have that so that you can check your work. All right. Sorry, this video is getting a little bit long, but there's a lot to do in this one. So example 1, we have this figure on the right side. Do your best to draw that. Again, it doesn't have to be perfect, but take your time so that you can at least see what's going on with it. First thing we're going to do is name it. So we're going to start by looking at the base, which is down here. And that base has 1, 2, 3, 4, 5, 6 sides. So a 6-sided polygon is called a hexagon. So this is going to be a hexagonal or hexagonal. And then look at your faces. This time, they're not rectangles, they're triangles. So if they're triangles, it is a pyramid. So the name of that polyhedron is a hexagonal pyramid. And now we're going to go through and do faces, edges, and vertices. Now for faces, we have to count all the flat parts. So we do have to count the base, we have to count the bottom, and then we need to count all 6 of these triangles. I get 6 of them? Yeah, I did have 6 of them. I ended up with 7. All 6 of those triangles around the lateral sides. Okay, so we actually end up with 7 faces. Okay, for edges, we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. And then vertices, there won't be as many. We have all of the corners down here, so there should be 6 of them, plus the one pointy spot on the top. So 7 vertices, okay? Now we can use Euler's formula to check our work. Okay, so remember how that works? Euler's formula says faces plus vertices minus 2 should be equal to edges. So if we check our work, faces is 7, vertices is 7, minus 2 equals 12. Is that true? Yes. 7 plus 7 is 14, minus 2 is 12. So we got it right. All right, and then one final example here. I put this one on here on purpose because this one tends to trick people sometimes, okay? So I think why this one is tricky to people is they see triangles and are like, that's a pyramid. It's not a pyramid, okay? It's actually a prism. It's not a pyramid because it doesn't have that one like pointy top. Like this does not look like something that you would see in Egypt. This looks like a tent, okay? So not a pyramid. What it is it is something that has triangular bases. Those are our bases. So it's triangular. And then see how it has rectangle sides? 1 rectangle, 2 rectangles, 3 rectangles. So it has rectangular sides. So it's a triangular prism. All right. And then let's go through and count faces, vertices, and edges. So faces, 1 front, 1 back, and then 3 along the sides. 1, 2, 3. So that would be 5 faces. Edges, 1, 2, 3, 4, 5, 6, 7, 8, 9. Double check and make sure we got them all. Looks like it. Yep, 9 edges. And then vertices, remember, are those pointy spots. So 1, 2, 3, 4, 5, 6 pointy spots. Okay, so let's use Euler's formula. So again, Euler's formula says faces plus vertices minus 2 equals edges. So if we try it, 5 plus 6 minus 2 equals 9. Is that true? 5 plus 6 is 11. 11 minus 2 is 9. Yes, we got it right. Alrighty, sorry for the long video. The rest of them will not be this long, this unit. So go ahead and do practice 11.1.